Hello and welcome to another item of Effective Java, and we're going to look at item 3, which is all about singletons. And you probably are already familiar with the design patterns, and one of the design patterns is also singleton. So this item is closely related to the singleton design pattern, and it says that enforce singleton property with a private constructor or an enum type. So what it means is that so first of all, what is a singleton? A singleton means there is one instance of a class or object, right? Maybe I should here say class. There is one instance of a class per JVM, right? Not per thread, per JVM, which means when you launch a JVM, there can only exist one instance of that particular class. Now, this means that this class is not a pure utility class, which means this class, a singleton class can have an instance, which means it can have a state, right? So if you're familiar with the utility classes, they usually don't have a state. They're just static fields or static methods, right? However, singleton can have a state, but then we want to enforce that there's only one instance of that particular class per JVM. And use it when it doesn't make sense to have multiple instances. For example, a database connection, you only want one instance of an object to be able to handle the connection to the database, talking to that. Or for example, in general, having a system.in and system.out, it doesn't make sense to have multiple system.ins or system.out. Note that, for example, here system.out out here is an object of type printstream, and the printstream class is not a singleton, right? So you can, but it's an abstract class, I believe, so you can inherit from it and develop your own version of the printstream. But the reason I mentioned system.in and out here is that it doesn't make sense when you launch a JVM to have multiple system.out, right? It just makes sense to only one of them, because these are just streams, right? These are just protocols that tell JVM how to, for example, system.out tells JVM how to send data to console or print them on the screen, etc., right? It doesn't make sense to have multiple of these. However, a class like runtime, it also doesn't make sense to have multiple runtimes, but runtime is definitely an implementation of a singleton. Now, what are the properties of a singleton? A private constructor, you want to definitely avoid the others, the users or the clients of your code, to be able to instantiate it. So what you do here, I have a picture of the runtime class, and you make the constructor private. So this line, this runtime, is a basically red square, which means it's a private method. So, and it's the constructor, it has a C, which means this is the constructor, and it's a private constructor. And then the other thing that you do, you create a private static final instance of that object inside the class itself, right? So it's a static final and it's a private, and you can make it also public. So there are two ways here. You either make the only instance, which in the runtime class is called current runtime. It's more customary to just call it instance, right? And then you either make it a public static final, or you make it private and then provide a static factory method or a static getter method. So the reason we don't call it a simple getter, because getters usually are not static, but here, because the class is private, you cannot instantiate it. You have to define the getter as a static method, which in the case of runtime, you have this get runtime method. So this is not a simple getter, it's more like a factory method, because factory methods are static. That's why and this get runtime is also static. And again, it's more customary to call it get instance, and it's a public static field, public static method, and as you can see, it returns a runtime object. So you provide some sort of access to the only instance of that particular class, right? So properties of the singleton, private constructor, and then the question is, when do we create that instance? And there are two ways of creating that unique instance. You do it either by eager initialization or lazy initialization. And in the runtime class, I have this screenshot here. It's an eager initialization, which means that as soon as the runtime class is loaded into the memory, obviously the JVM is going to initialize all the static fields. And this static field current runtime is an instance of an object, so it's a reference type. And if you don't initialize it, it's going to get its default value, which is null. But here we are eagerly initializing this. So when JVM loads this class into the memory for the first time, this current runtime is going to be initialized, right? Now, sometimes you don't want this to happen. You don't want eager initialization, and you probably can guess when that case is. And that's when initializing the object is costly. Maybe it takes a lot of time. For example, in terms of the database connection, you might need to do a lot of checks and a lot of stuff. You might need to load a lot of data into the memory, etc. So sometimes it doesn't make sense to eagerly initialize the class, right? So again, you either define a private static final field with the name instance, or in case of the runtime, it's called current runtime. It's up to you what the name should be, but usually it's instance. And obviously it's because this is a static final field, you make it or capitalize like this, right? That's the convention. And then you can create a public method, and this is a static, because you cannot instantiate the class, so you have to provide a static way of getting the instance. Public static method, and as I mentioned, this is not a simple getter, right? Because getter methods in an instance of a class, they're not static, right? So this is more like a static factory method, right? So I'm going to put it here in brackets, factory method. So this is a way to let the user be able to get a hold of that instance. So get instance, in case of the runtime class, it's called get runtime, right? So you provide a static factory method that returns the reference to that particular instance. And again, in the runtime class, it's eagerly initialized because this class doesn't have any data, it doesn't do anything, so it's a very lightweight class, right? So initializing it eagerly doesn't have any real cost. But obviously sometimes you definitely don't want to do that. You want to go the lazy initialization route, and that's because again initializing at the time when the JVM loads the class into the memory might be very costly, and you want to wait until somebody really needs to use this class, really needs to use the singleton. Now the problem with, obviously the benefit is that, okay, you defer the initialization or the creation of the unique instance until somebody really needs it. But then there are some problems associated with this lazy initialization. One of them, especially about multi-threading, which race conditions happens, because assume that this runtime instance is null, right? It's not eagerly initialized, and somebody wants to get you have multiple threads, and multiple threads want to get a hold of this instance. So obviously in the get runtime, you have to check first if the current runtime has been initialized or not. If not, you initialize it and return the instance, and then the question is which thread gets to initialize the object first, right? That's the problem. And there are two popular solutions to avoid race conditions for lazy initialization. One of them is a static nested in a class approach. The other one is double check locking. Again, this is not a course or a topic or a detailed discussion on singleton, but I'm just mentioning these here so that you are familiar with the terminologies or the approaches that people usually use, right? So let's head to Eclipse and try to implement a very simple singleton and explore the eager and lazy initialization approaches. So I'm going to go to source folder, create a package, item 3, and then let's create a class, my singleton, right? And what are the properties of the singleton? Private constructor. So private my singleton, we're going to prevent anyone from accessing this. And then we said that we have we can go private static final field instance, all right? And I'm not going to initialize it here. Obviously, if you go the final, if you go the final route, if you use the keyword final, you have to initialize it somewhere, either in the constructor or basically just say new my singleton. Okay. private static final, and we have to give it the type, right? And again, if I don't use this, don't initialize it, it's going to complain, says that you have to initialize it somewhere. We can just initialize it right here, right? And then we provide a public factory method. And again, it's not a getter method, because getter means it's not getters are not static by definition. So public static my singleton and get instance, right? And this getter, the factor method, doesn't take anything and then returns the instance, right? So let's create a test class and have a main method here. And let's again, singleton can have a state, right? So we might have some parameters, let's say double x and y, and then we initialize this. We can just initialize this in the constructor, for example. Again, singleton can have a state, so it's not a purely utility class. It can have a state, but it doesn't make sense if there is more than one instance here. So let's say we can, for example, override the toString method here, right? So anybody can anybody that accesses this get instance gets the same instance, and then basically they all see the same state for this in singleton. And we typically don't provide any setters, or we might, but it's not typical for a singleton to have a setter method. But again, because singletons can have a state, you can in fact provide setters to, if somebody wants to change the state, they can, right? And we can in fact provide a setter, public void set x, for example, double x, this dot x equals x, and we can also provide a setter for y, right? So set y, y, and then this dot y equals y. So now we are allowing people to change the state or modify the state of the unique instance of this class, right? There can only be one instance per JVM. All right, so let's go to our test class here. I'm going to we have a main, and I'm going to say var instance is my singleton get instance, right? Everybody sees the same instance. And then we do a sysout here instance. All right, and we get the same state, and then I can change the state, set x 5, and then sysout instance. Okay, and now the state has changed, but there is only one instance still, right? And again, this is the eager initialization, so I'm going to write it here, eager initialization. And again, the eager right now our class is very lightweight, so it's very easy to eagerly initialize it. And eager initialization automatically prevents all the problems with multi-threading. So I'm going to create another, so let's move all this code into a static method, public static void test. Let's call this test1, which was just testing the singleton, right? Test1. So this code still works. Yes. And now I'm going to create another one, public static void test2. Now what I'm going to do in test2 is create multiple threads. So int num threads is 10, or maybe let's say 5, and then try to, so that each thread tries to get a hold of this instance and does something with it. Now obviously mutating the state is has a fundamental problem with multi-threading, but even if we don't allow this, right, we see that when you go eager initialization, multi-threading has no problem. All the threads always see the same state. It's always consistent. So let's see. So we have 5 threads for int I equals 0, I less than num threads, I plus plus. I'm going to say so let's create a runnable. R is so it's a lambda expression. What we're going to do is saying that var instance. So we're going to get this. Let's go multi-line for our runnable. We get a hold of instance and sys out instance, right? That's our runnable. And then we're going to create a new thread and then pass in our runnable and then start, right? So we're going to basically start them. So all of them see the same basically state, right? And then what happens if we go the lazy initialization route? So in the lazy initialization, so I'm going to comment the previous one. We're going to stay with null. So obviously, if you don't set it to equal to anything, it's going to be null by default. JVM will initialize this with null. So JVM will initialize this with null. It's equivalent to explicitly write it to null. It's not necessary because that's a default value anyways. And then note that we couldn't use final anymore, because when you have a final you have to initialize it at least in the constructor. But now we're not doing that. And now for the lazy initialization, the simplest approach is to check that if instance equals null, we're going to initialize it. So instance equals new my singleton, right? And then the x and y get initialized. Note that when this is not the instance is null, x and y is 0 0, right? And then we return it. So we just add this simple check for lazy initialization, and let's run this. And all of these work fine. And let's see, let's have 10 threads, for example. Now all of them work fine, right? So the first thread initializes this, and then note that if we don't add this, nobody can initialize this. And then but then if we want to mutate the state, then x and y, these setters allow some to mutate the state. For example, we can say instance set x 5, and then the thread starts, sys out, or we can just say sys out instance again. And then let's do a sys out here, thread, and then %s, or yeah, we can just say printf it, %s. All right, and then thread dot name or get name, thread dot current thread get name. Let's see what we get here, and then \n. So all of these, as you can see, the order is basically different, right? It's not in order as we expect that. So we create our runnable, and then some threads. So let's remove the first. We get a hold of the instance, some mutated, and we print it again. And all of them seem to be very consistent in this case, right? So again, for lazy initialization, we can do instance, right? We just add this check, and then this means that anyone, basically the first person or the first call to this get instance, we initialize it, and unless somebody explicitly needs to work with this instance, we're not going to initialize it if the initialization is costly. Now, in terms of private static nested class for initialization, we can say public static class, we can call it impel, right? And here basically what we can do, we can put this inside the instance, right? We can put the instance of the outer class inside the inner. We initialize it inside, and then we say public, or we can make this public, right? And then in the instance, we can just, instead of checking for null and initializing it, we can just say return impel instance, something like that. This should also work, but the difference here is that this guarantees a thread safety if there is a problem with race condition. So let's also test this, and everything seems to work fine, as you can see, and we still work. So it's always my recommendation is try to use this one, and obviously you can make this class private because we can still access this private implementation in the impel, and then this guarantees the thread safety. So back to the course, back to the PowerPoints. Okay, let's see what the book has to say about singletons. And so again, item 3 is about enforce the singleton property with a private constructor or an enum time. And again, enums are also good because enums always have a private constructor. You cannot expose the constructor of the enum to the clients, to the users, right? It's just baked into the language. So the book says a singleton is simply a class that is instantiated exactly once, right? So again, the difference between a utility class, which doesn't have any state, everything inside a utility class is either public field, static fields, or a static method. But a singleton is not like that. A singleton can have a state, but then it doesn't make sense to have more than one instance of that class. Singletons typically represent either a stateless object, such as a function, or a method, a utility class with a static method. And if you look at again some classes that are inside Java lang, for example, math class, it has a private constructor, right? It's a purely utility class. It doesn't have any state, and it has a private constructor, right? So it's more or less like a singleton, but the difference here is that it's not really a singleton because you cannot really instantiate it. There is no instance of the math class when you run the JVM. There can never be, because it's a utility class. It doesn't have any state. Everything inside the math class is static, right? Or a system component that is intrinsically unique. Again, for example, a database connection, it doesn't make sense to have more than one instance of a class that handles the database, and that instance can in fact have a state, right? Making a class a singleton can make it difficult to test its clients, because it's impossible to substitute a mock implementation for singleton. You cannot inherit from it. You cannot override any method, right? Because a private constructor means this class is closed to the outside world. And unless it implements an interface that serves as its type, right? Again, singleton is still a class, so it can implement interfaces. And mock implementation means you cannot, that class has a type, right? Just like any other class, and sometimes you want to have a dummy instance instead of the actual implementation to test some aspects of that class. And having a singleton and not being to change its behavior or its implementation makes it really difficult, or sometimes impossible to test it, right? It's not impossible, but it's very difficult. Unless it implements an interface that serves as its type, a privileged client can invoke the private constructor reflectively. So reflection is always a problem. You have to be very careful. If you really want to prevent anyone, you have to maybe throw some sort of exception if somebody tries to access the constructor anyways, right? With the aid of the constructor, so you can get you can say the singleton class and then they get declared constructors, for example, and then you just set the accessible to true, right? So whenever you have a private field, private method or private constructor, whatever, if you just set the accessible to true, it means you have already defeated the basically access modifier that was declared in the class file, right? If you need to defend against this attack, modify the constructor to make it throw an exception if it's asked to create a second instance, right? Yes, so you can check if the instance has been initialized inside your singleton. If it is, and then in the constructor you can throw an exception if somebody tries to call it a second time. There are two common ways to implement singletons. Both are based on keeping the constructor private, so this is the very important part, and exporting a public static member. So you either make the instance public static and then it's final, and then you or it can be private, and then if you expose the instance itself, then basically you have no choice to eagerly initialize it, because then because people can directly access this, right? So the first approach is to having a public static member that is the reference to that unique instance to provide access to those sole instance. And again, the problem with this is you have to go with the eager initialization. The second approach, as I mentioned, is a factory static method. So the first approach is public static final instance, and if you go this so I'm going to remove the boldness here. Final, if you go with the final, note that if you go with the final, then you have to go with the eager initialization, because people can directly get access to this without calling any constructors. Then you have to ensure and provide the guarantee that this instance has been initialized or the instance has been created. So but the public field is easier because API makes it clear that the class is a singleton. The public static field is final, so it will always contain the same object reference. It is simpler, right? There's the instance, you get a hold of the instance. Approach 2 is the static factory method. I'm going to add the static here. A static factory method, get instance or get runtime or whatever. It gives you the flexibility to change your mind about whether the class is a singleton without changing its API. So here, with the first approach, you are doomed that you cannot change this interface, right? It has to be public static field. But here you can change the implementation because there is some level of encapsulation with providing a factory method instead of direct access to the instance. So it gives you more flexibility. You can write a generic singleton factory. So this factory method can be parameterized if your application requires it. A method reference can be used as a supplier. So again, this is a static method, so you can always use it as a supplier by you taking advantage of the method reference paradigm, which comes with the Lambda expressions. So whenever you need to provide a factory method as a supplier that gives the client the access to the instance, you can use it as a method reference. You say the name of the singleton class, colon, the scope resolution, and then get runtime. It's a method reference. In our case, it's my singleton, colon, get instance. So this is a method reference. So this is a very nice thing because sometimes you have to provide a supplier. There are cases that Java has some sort of limitation, especially when you're dealing with generics. You cannot call, if you have a generic type T, you cannot call the constructor. You cannot say T parentheses and try to construct with the type parameter because of the type erasure in Java, right? So in those cases, you have to provide a supplier that tells the client how to generate that object. So a singleton, you provide a static factory method to get a hold of the instance. And the singletons have in general a problem with serialization. That's because so when you serialize and deserialize, JVM will create an instance anyways, right? Regardless of it's supposed to be a unique instance or not, right? So to maintain the singleton guarantee, declare all instance fields inside your singleton. Now, if your singleton has a state, then it's going to have some instance fields that are not static, right? That's part of the state. You declare them transient and provide a readResolve method. So what happens here is that if you don't do this, if you don't provide readResolve, JVM will create when you serialize and then deserialize, JVM will create a new instance. That's the problem, and they solve this problem by you can solve the problem by providing readResolve method, which has a unique signature. So you have to adhere to what the Java language specification or the JDK specification says about readResolve. And when you do this, and then you hint to the JVM is that, hey, when you're deserializing it, disregard what was deserialized and return this whatever this method returns, right? So this method readResolve returns an object, and you're going to tell JVM, when you deserialize, disregard it, just return whatever object that I'm specifying. So if I hit to Eclipse, go back to Eclipse and try to look for serialization or serializable interface. And this is still a marker interface, but so it doesn't have any method inside of it. So where is this readResolve? So this readResolve is actually not part of the serializable interface, and the reason, I guess, is because of the backward compatibility. So you're not forced to implement readResolve, but if you implement it, then it hints the JVM that I want you to return whatever object that this method returns when you deserialize. So if I open up the documentation for the let's see, for the serializable interface, there are some special methods that you're not part of the serializable interface, so you're not forced to implement them. But if you provide them inside your serializable class, inside any class that implements serializable, then these methods give JVM some sort of instruction or hint that what you really want to do, right? Now, obviously, serial version UID, this is something that you can provide. This is not a method, but write, replace, and readResolve. So what is this readResolve? The classes that need to designate a replacement when an instance of it is read from the stream should implement this special method with the exact signature. You can have any access modifier here, private, protected, whatever. It has to return an object, and the name should be readResolve, and you don't really need to specify this exception, so you can comment it out. But when you do the readResolve, then inside the implementation you can instruct the JVM what you want to actually be returned. And what you do here is that, so if I want to make my interface singleton serializable implements serializable, right? And we're going to provide the serial version UID, which we start with the 1, and then and then what we're going to do here is we actually don't need this here anymore because we are using the static inner class. And then what we're going to do, we can provide the readResolve method. So we can provide a private, and then it's going to return an object, readResolve. And we're going to tell the JVM, so if we're going to return impl.instance. So what happens here is that it tells JVM when you deserialize this, obviously it's not going to invoke the constructor, so X and Y are going to be 0 by default, right? And then what happens here is that if you don't provide this, JVM actually creates a new instance behind the scenes and assigns X and Y to 0. Let's try this. Let's test this. So public static void test3. So I'm going to say var instance. So let's invoke test3 here. So I'm going to get a hold of my singleton, my singleton dot get instance. Let's do a sysout on the instance. So obviously we expect to see the state of our object 1.1, 2.2, and I'm going to serialize it var object output stream, new object output stream, and we can put it in try with resources. Var os new object output stream. It requires an output stream, and then a new file output stream, and I'm just going to put it in the current working directory. Let's say singleton.bin for binary, right? So, and this is going to throw exceptions. We're going to catch them, so let's catch them. And try with resources automatically calls the close. That's fine. So what are we going to do here? We're going to basically say OS object output stream right, and then we can just say object, right object, and then instance. So right now we are serializing this. So if I run this, we're going to get the instance, right? So if I refresh, so in JVM, when you launch your application, if I go to run configuration, as you can see, the default working directory is the top level of your project folder, right? And as you can see, it had already added this binary, right? So my singleton, some stuff, this is binary representation of my class. And X and Y were serialized because I did not specify these as transient, right? So these are going to be serialized. Now what happens if we deserialize? So we are serializing the singleton, and then after that we're going to deserializing the singleton. So with deserialization, the code is very similar. Object input stream, OIS, new object input stream, and file output, file input stream, right? And it takes a file singleton.bin, and again, the exceptions are basically this. Instead of saying write object, we're going to say read object. And it already knows what to read. Let's remove the exceptions here, and let's see what exceptions we're going to catch. Let's catch everything, and read object is also going to throw exceptions. So we're going to add these together. File not found exception, because we are doing a file operation. IO exceptions, if something goes wrong with opening the file. Class not, if we were able to successfully get the hold of this object input stream, but we cannot read this object, or the class is not available on the class path, right? If class is not available on the class path, it's going to throw this class not found exception, or no class def error, something like that. So we're going to read the object, and var instance, we're going to now obviously var obj1, right? And we can also cast it to my singleton, that's fine. And let's do a sysout on this obj1. Let's see what happens. And note that I commented this readResolve, so let's see what happens. So let's actually do a sysout here and write these to the console, right? And then let's do another sysout here, and then deserializing the singleton, and let's run this. And as you can see, JVM is smart enough to realize that, okay, x11 and y 2.2, this is what was happened. So they have made improvement to the JVM, right? So I'm using Java 15, so they have made it smart. But we can also provide this readResolve, and let's do a sysout here, invoking readResolve. And let's see what happens when we run this. As you can see, it in fact invokes the readResolve, and then returns the singleton. Now note that the reason that this still works is because we are using this way of implementation, which is very nice way. So this is the recommended way, or at least the way I recommend it, but let's not do this. So let's go with the original version of eager initialization right inside the singleton, right? And then we're going to return the instance with eager initialization. So let's return the instance directly. All right, so we're not using the static nested class, but then let's run this. Singleton, serializing the singleton, deserializing the singleton, and the singleton still works. What about if we go lazy initialization route? So we are not initializing this, we are doing this, right? And then let's see. Yeah, so let's see what happens in this case with lazy initialization. It still works fine. And if I uncomment this readResolve, let's see if this still gets invoked. Yes, invoking readResolve. So this proves that when JVM deserializes, it actually invokes the readResolve method. And then you can give JVM instructions of what object to return here, right? When you deserialize, you can tell it ignore whatever you had for the X and Y, for example, or and then basically invoke. Now, what happens if I declare these as transient? Invoking readResolve, and now this works, it still works. But what about I comment this, and now this doesn't work, right? So when you don't want to when you don't want to have to save the state of the singleton, maybe it's a heavy or costly operation, there's a lot of data in the singleton. What you can do, you can provide this readResolve again, and this readResolve, you create your own object the way you want it, and then you tell the JVM when you deserialize, ignore the whatever data you read for the state, and instead return this instance. And as you can see, this still works, right? And so back to the PowerPoints. So let's summarize the item 3, singleton, which is relatively important in some cases. So that's why I put a lot of discuss some details, right? So we mentioned that there are two approaches, right? Either you give a public access to the instance and then you have to eagerly initialize it, or you provide a static factory method get instance and then you can lazily also initialize it. You have to take care with serialization. It's best practice to provide the readResolve, and whenever JVM deserializes the object, it actually invokes this readResolve method if it's present, and then returns, and this readResolve returns an object. So JVM actually returns whatever this method readResolve returns, right? So this was the end of item 3. I'll see you in the next one.